All right, in this chapter, we're talking about the control of quality in a manufacturing process. It can be a service process too. But and the first thing we're going to work on is what's called a Taguchi loss function. And it basically it's a way of measuring when something is not exactly to standard, how much is the loss? And the loss comes from two things. It can come from the warranty costs that you may have, but there is also opportunity and reputational costs that can go on this. And so there is a formula for the Taguchi loss function. And the formula is L, which stands for loss, and then we use the X, which is the loss at point X. So this is what our product actually measured at was at point X. And that's going to equal K, and K is a constant for each product that we have. So it's not like a universal constant like the speed of light or something like that, but it's a constant for each product that we have. And then we multiply that times X minus T. T is the target, and we square that. So as you can see, if this is the target and this is what we actually came in at, if we're the same, right, then that comes to zero, and so our loss is zero, right? So if this is the same, if X equals T, then this term becomes zero, and so the whole loss becomes zero. But one of the things that happens, so it doesn't matter if X is larger or smaller than T, by squaring it, it becomes a positive number, which means our loss will be a positive number, if you want to think of a loss as a positive number. And so that's the basic Taguchi loss function. And so in this particular problem, 17-13, that we have a product specification of 75 plus or minus 5. So we could go from 70 to 80 on this, but 75 is the target value here. And so we know that the loss is $500 per unit when we are at 80. And so it wants us to calculate K. So this is just going to be an algebraic exercise. So we know that Lx is 500 when X is 80 and the target is 75 squared. So we get 500 equals K 5 squared. 500 equals K 25. 500 divided by 25 equals K equals 20. So our loss factor, the constant there on this one, is going to be 20. So that's the loss function. Okay. Now, 17-14 also uses this particular data, and it says refer to the information in exercise 17-13 and calculate the estimated total quality loss when measured characteristics is 78. Round your answer to the nearest whole number. Okay, so now we just plug 78 into our loss function. So we're going to have L at 78. Loss at 0.78 equals K, which we now know is 20, times 78 minus 75 squared. So that's going to equal 20 times 3 squared equals 20 times 9 equals 180. Okay, so that would be exercise 17-14 on that one. And then finally, 17-15 uses the same data again, refer to that information in exercise 7-13. What is the expected average loss per unit based on the Taguchi loss function if the manufacturing process is centered on the target specification with a standard deviation of 2? Okay, so with a standard deviation of 2, we're going to have the expected loss, right, of X. E is for the expected loss, equals K. Standard deviation is just the variance squared plus D squared equals 20 times 2 squared. So 2 squared plus 0 squared, since there's no deviation from that. And so that's going to be, that'd be 4, so that would be 80 on that. All right, so so that's what happens if we go in terms of standard deviation. All right, so that's brief exercises 17, 13, 14, and 15.